Hi, in this video we will focus on how can we use this insight and how can we interpret this data and how we can compare different design options. So as you know, insight, this is from Revit, so this is the energy model we call it. We have tools that we can use to navigate through the model similar to other 3D modeling tools, but actually when you submit or when you click on the link of insight, you will come here, but you will see here, you will see cost, which is a number, USD dollar by meter square by year. So actually when you click here, it will be the EUI, energy usage intensity. So it's the unit is kilowatt hour per meter square per year, and we are interested to use this one. So please, when you in the beginning, when the model is like this, don't change anything and click here. Sorry, here, this one, add scenario. Why? You will understand why. Just click here, and then this entitled scenario, call it reference model. So before you change anything, reference model. So now what do we mean by the reference model? We mean this is our reference model, isn't it? So we didn't change anything. So it has the materials that it is in Revit, it has the geometry that it is in Revit, it has the orientation which is in Revit, and according to insight calculation, this is the EUI of the reference model. Here is the location, so no need to change it from here because you already assigned or set up this location in Revit. Now this is the kind of a benchmark which shows your the current EUI compared to some standards like ASHRAE 90.1 and Architecture 2030. As you can see, for ASHRAE we are compliant. It's less than the standard, which is required to be 280, which means it's already a good thing. Now for Architecture 2030, they request for 94 kilowatt hour per meter square per year, but we didn't really reach this energy consumption. So remember, when we say 248 kilowatt per meter square per year, this means the building consumes this amount of energy per year, this amount of kilowatt hour per meter square per year. You have to understand this. Now these that we call them factors, or we call them factors, and in each factor there is different design options that we can play with. Now what I can do, I can click actually on this building orientation. Here I can click here, so I will see the options. So these are the options, and this is what we call a range, but we will not be able to change the range unless we click on the icon. So what we are seeing here, it's like we are seeing the factor, which is the orientation, and we will see how it will impact the overall EUI of the building. And the good thing, we have this kind of diagram. So the triangle shows the current situation of the BIM model. So if I want to improve, so if I want to decrease the EUI by 0.76, so actually I have to select this option, which is the orientation will be 270 compared to the true north of the building, of the project. So there is another orientation which looks better, so, and actually it's the best since there is no other options here. So I will decrease the overall EUI by minus 1.44 kilowatt hour per meter square. So this way is the worst one, so 8.74. Currently there is no option has been selected actually, and basically we are working with the BIM model. Nothing has been selected. Now if I want to select this one, for example, I will take this to here. As you can see, already there is a reduction of the EUI. So now I did a changement already, and if I can see that the last change that I did, it's here actually, These one I did them before, so this one is like the model history. As you can see, any changes you do, it will show you. It's like you will be able to compare before you reduce how much it was now. So we are saving 3.34 kilowatt hour per meter square per year, just because of that orientation. Anyway, we continue, for example, for WWR of southern wall. So I click and I can see my current situation, which is WWR of the southern wall is here. So it's 25%, and we are saving 2 kilowatt hour per meter square per year because of this orientation. But actually there is better option. So if the WWR is 15%, so there will be a saving minus or 7.27 kilowatt hour per meter square per year. And there is even one which is better than all of them. So using this, which is 0%, so this means WWR is 0, which means there is no windows in that facade, but possibly it's not possible to select this kind of design option. And when you are not sure which for example, maybe you are planning to change the WWR between 50% and between 30%. So what you will do, you make kind of a range. So Revit will, sorry, Insight will try to calculate like the average, and so the EUI in the average will be 255. If since I'm not sure which exact WWR. So for this one is for range. If you are planning for only one, you just make it like selecting only one or in the range of only one option. Of course, this one will be recorded also. Wait, it will come here and I will see WWR southern wall. So we saved 4.67 because of this design option. Of course, it's decreasing here. As you can see, it has become 240. If I go, for example, let me see this. This one is WWR also. This one is shading devices. As you can see, yeah, there is some saving. We can get it from here. Okay, let's go to what is wall construction. I think this one. Yeah, wall construction. I already modified this. Before it was like this. So our wall construction in this case in the BIM model, so we are not saving anything. We can save 21 kilowatt hour per meter square if we use the option which is called R13 plus R10 metal. You can search what this kind of walls means in the internet, R13 walls or R10, and as you can see there is different other options. This is the best one basically, and this is the worst one. So in insulated wall, for example, if you select only this one, it's really terrible, the EUI. You see, the good thing is like on the fly you can get good results. Energy consumption, it's like a very important thing. You can get it just by changing like a range or a cursor like this. Yeah, so this is basically the best option. So basically, because in the assigned brief, this one number 6, so based on Autodesk Insight simulation platform, discuss different design alternatives that could be considered in order to reduce the EUI. So basically we'll need to discuss these, the ones that we talked about. So as you can see that we can change the orientation, we can change the shaded devices, we can change materials. For example, for WWR we mentioned that it's not possible to make it 0%, even though it's the perfect one, but we cannot do it because otherwise there will be no windows. So just discuss generally. And yeah, you can give numbers also. You can give numbers and you can take screenshot and show like you changed one to another one and look to the result. So you can change anything anyway, so there is many factors that have an impact on this EUI. But remember that we have created a reference model, and the reference model contains the very beginning, the very first information of the model. So here, as you can see, it was 248, the reference model. Okay, now in the next video we'll see the how to compare scenarios in the next video, because there is this one: use Insight to create multiple design scenarios to reduce the EUI, and then generate a comparison diagram of the EUI of the different scenario compared to the reference model. Okay, see you in the next video.